Okay, so today I'm going to be talking about sub-lifetimes and scratch arenas. Now in the previous video I showed you guys this example of a linked list which is being stored on an arena. Now let's say I allocate 2 more nodes on this linked list, so we have 4 and 5. So here we have 4 and then here we've got 5, right? So what happens if I want to remove the 2 elements 4 and 5, and that's it, so no other elements. So I don't want to free the whole arena, I just want to free the 2 elements 4 and 5. With our current approach to arenas, that's impossible because the arena is either wiped entirely or we keep all the elements there. However, this is quite irritating because there are situations where we have small groups of elements which we want to free together, but we want to keep the rest of them still alive so we can use them later. So how can we do that with arenas? Well, there is an approach which is called temporary arenas. So here I've got a temp struct which has a pointer to an arena, then it has a 64-bit integer called original offset. Now this temp arena is going to have 2 functions. Temp begin, which is just going to create a temporary arena with the arena I give it, and then temp end, which just resets the offset of the arena back to the original offset. Now the reason this is very useful is because we can create a temp arena at a certain point, add some elements on that temp arena, and we can just free it. So we just reset the pointer of the arena inside of it to the original value it was. So we effectively just free the elements for free. So I'll show you guys what I mean by that with an example. So here I've got back the example of the 5 nodes, and let's say instead of using just the main arena, I construct a temporary arena and store the nodes 4 and 5 on there. So here I've created a temp arena, and then I use arena unlock with temp arena as well. So what does this actually mean? Well, you see elements 4 and 5 are now being stored on the temporary arena. So what we can do now is run a function like temp end, which will reset the pointer of temp arena back to the original offset it was assigned when we created it. So here when we're creating temp arena, the original offset of the arena was 24, which is going to be at element 3, so at the end of it. So when we do temp end, it just resets the pointer back to that value. So we effectively just freed those 2 elements with that. Now we can build upon this idea of a temporary arena with something called scratch arenas, right? Now commonly when we're programming in C, we have a pattern like this. So we have something which takes in, let's say, a string or some object. We have to create a copy of the object which we will manipulate in the function, and then during the function we have to create a bunch of temporary heap allocations which we have to free afterwards, but they're just there because we need to dynamically resize them, or for some other reason it's more convenient to have it on the heap rather than stack. So normally it will look something like this. I have got the string which I'm going to remove the white space of in this example. I make a copy of that which I'm going to manipulate, and then I return that afterwards. Then I have 2 temporary allocations which I have to free down there. So temp alloc 1, temp alloc 2. Now this is error prone because if I forget to free temporary allocation 1 or temporary allocation 2, I get a memory leak, right? Now how can we use arenas to solve this? Well, then we can use something known as a scratch arena. Now a scratch arena is supposed to be a temp there, but I'll change that later. So we pass in 2 arenas here. We've got the main arena which we're going to store the string copy on, and then we have our scratch arena which we do all of our manipulation of. So here I've stored the string copy on the main arena, which I'm going to return, and then all the temporary allocations are now on the scratch arena. Now when I do something like temp free there, I can just free all the memory inside of the scratch arena. And the whole idea of the scratch arena is that it's just for temporary allocations. So it doesn't matter if I reset the pointer or I free the whole arena, it's fine, because it will just be used in another. So I'm going to show you guys how we can create temporary and scratch arenas right now. So here I've got the code from the last tutorial, where we just created a dynamic arena, and I'm going to add some code to it to first create a temporary arena. So the first thing we have to do is create a struct called temp, and this will just hold a pointer to an arena, and then it also have a uint64t called original offset, and this just tells us the offset of the arena when we first created the temporary arena, so we can just reset to it and just free the elements that we had in the temporary arena. So it's going to need to have 3 functions. So the first one is going to be temp begin, So just take in an arena, and this will just return a temporary arena with arena being set to arena and the original offset being arena's current offset. We have another function here called temp end, and this just takes in a temporary arena, and this will just set the arena's current offset to be equal to the offset of the arena, of the original offset. So that's all we actually need to create temporary arenas. It's quite simple, but what we can do here is, let's say I've got this arena in it, I do something like here, temp begin arena, and then here I just pass in temp.arena instead. Right, and instead of doing arena delete, I can just do temp end. If I compile this, taking some time. Yeah, there we go. And then this just created a temporary arena, right? So all the data right here which we allocated was just freed automatically for us at temp end, because we just reset the pointer to 0. If I did something here like, I don't know, I allocate a string, when I do temp end, the arena's offset should be 100. That's the original value it had. Right, is 100. So before I created the temp arena, we had an offset of 100 because it's 100 bytes for the string which I allocated. Then we created a temp arena, we created these temporary allocations, then we reset the pointer back to the original offset, which was 100, right? That's pretty cool. Now we can create scratch arenas. Now scratch arenas are a bit more complicated because we have to handle some edge cases because of how we use them. So here I'm going to first create a function called scratch get free. Now scratch get free is going to take in 4 arguments. So the first argument is going to be an array of arenas. I call these, let's say, arena pool. Then I have an integer called arena pool size. I have another arena called conflicting arenas. Let's say int conflicting arenas size. Now the thing is, commonly whenever we're writing code with scratch arenas, we're going to pass in, we usually have nested function calls. So let's say I've got, I don't know, void foo takes in one arena, right? The main arena we're going to return the value of. We're going to store our final result in. Then we're going to have a scratch arena. And then I do some stuff here that I return allocation on arena, right? And then here I've also created some allocation on scratch arena. I created some allocations here, right? Let's say I call another function called bar, and bar needs to have another arena, which is arena, and another temp arena, which is a scratch arena. Now the thing is, bar is going to return a value which is used as a temporary variable, is a temporary intermediate result which we need to calculate the final result. So I don't want to store this on the actual arena. I just want to store this in the scratch arena. So the way we have to do this then is pass another temp arena, let's say scratch 2, and then I have my main scratch where I want to return this value. Let's call this arena. And then I have scratch 2 which I just pass in, and then I've got my other scratch which is going to be this thing here for bar to do its temporary allocations on. And as you can see, if I have more and more nested function calls, which we usually have in complex programs, I have to add more and more temporary arenas for each one. Now there's actually a trick to get around this, and that's cool. That's where we can just swap around two arenas. So what this means is, let's say we have foo, and the temporary arena stores, let's say int64, right? So let's say I've got scratch 1, and let's say scratch 2. Right, so scratch 1 has 64, 32. Foo added these two allocations on it. Now for the second function call, what we can do is we can pass in scratch 2. So let's say scratch 2 is string hello, right? And then there's this, let's say something, that's the other allocation it does. Those are two allocations it does. Right. Now instead of, if you've got another function call, we need another scratch arena for, instead of passing in scratch 3, we can create another temporary sub lifetime. We could make another sub lifetime on scratch 1. Then we could create another allocation, let's say something, let's say another float, and then another float, and then in the fourth function call we could do something else here. So let's say 23 spring. And then what happens is, as we unwind the stack, we end up having the results stored in the alternate arena. So let's say we finish calling function 1, the result is stored in scratch 1. We finish scratch 2, the result is stored in scratch. So we finish the third function call, the result is stored in scratch 2. We finish the second function call, the result is stored in scratch 1. So just hopping back and forth between these two arenas to just store temporary allocations. It's a pretty cool trick if you think about it. So we can implement this through this function right here, which is scratch get free. So we need to have a pool of arenas, which is just usually just 2 arenas per thread, and then we just have a conflicting arena, which is the other arena where we're storing the other scratch arena where we're storing the temporary allocations. So we just hop back and forth between this scratch arena is for the resulting allocation, and this scratch arena is just for temporary allocations. So I'm going to create a for loop here. Let's say for int I is equal to 0, I is less than arena pool size, I++. Then I say for int z is equal to 0, z is less than conflicting arenas, z++. What I want to do here is just find an arena which is not being used already. So it's a free arena we can just hop back and forth between. So I'll say pool is conflicting arena equal to false. So if arena pool at I is equal to conflicting arenas at z, then we know that this arena is being used to store a result. So then we just say is conflicting arena is equal to true, right? And then outside of this for loop, I'll just say if is not conflicting arena, we just return this current arena. Let's create a scratch. So we say temp begin at arena pool I, right? And then here we never actually get to this point, but the compiler gives us warnings if we don't add something here. So here I just return an empty scratch arena. Right, if I compile this, there should be conflicting arena size. There we go. Okay. Now I'm going to create another function called scratch free, and this is just for completeness. This is just gonna call temp end the scratch arena. Right. This is just so that we have a bit more. We've got 2 functions we can interface with for scratch. So I'm going to create a macro. Actually, before I do that, I'll just show you guys how we can use this. So here, instead of doing temp, I can just do temp scratch. So we're gonna have to, actually before that, I have to create a variable here, a static. I have to create a struct here. I call it thread context or context. So the way this works is that each thread is going to have a global variable called context, and it's going to contain at least 2 scratch arenas, and then we can add other stuff we need to. But the reason I created this global variable is because we have to create some macros to make it easier to interface with the scratch functions, and then you have to have some way to just pull in a pool of arenas out of nowhere, so it has to be stored in global. It has to be a global variable. So we'll create here an array of scratch arenas. Let's say scratch pool. Then I have another arena called, let's say, global arena for just allocations, whatever we want. So the only thing we actually need in this context is scratch pool, but we can add other arenas or other variables if we want. So here I just create a static variable called context, and then I'll initialize it down here. So say context dot scratch pool at 0 dot arena. I'm going to allocate that on the heap. The size of arena. Same for the first one, and then also the global arena. Then I also have to initialize this arena. So say arena init. Let's say 1 GB for each of them. Right. Compile this. So there's actually arena, so we don't need that. It's not a temp arena. If I just comment out the rest of this for now. Actually, now that I think about it, we don't have to initialize these two arenas, because whenever we create this the global variable, these two actually is an arena on the stack. So this will just create this on the so the way the memory works is that we have this segment in memory. Whenever we create a process, just store static variables. So the scratch arena, these two arenas will be stored there, and then the pointer to the global arena will be stored there. So we have to initialize the global arena with this, but we don't have to worry about the scratch arenas because they've already been created, the actual arena struct. So now if I run this works, and then yeah, there we go. So this is how we can create the arenas. And now if I want to use the arena, let's say temp scratch is equal to scratch get free. I'll say ctx dot scratch pool to currently we've got no arenas which actually are conflicting with, so we can just create a scratch arena like this. Okay guys, so it seems to be that the problem is with the types, so I have to turn this arena array into a pointer to two arenas. Right, then I can just allocate those two arenas right here. And then if I now run it, yeah, it should work. Then we can create the scratch arenas, and then I'll create a last macro here called define get scratch, which will just take in conflicting arenas, and then the number of conflicting arenas, and that'll just do scratch get free ctx scratch pool two conflicting arenas, and then the number. So instead of doing this here, we can just do something like get scratch, say conflicting arenas, right, 0 0, right, and then let's say for the function here we have something like void We could do temp scratch. Let's say get scratch. And then I call something here, say void foo. And then we can do temp scratch here again. So what's effectively do here is we can do something like call foo with scratch arena, and then this get scratch function which call scratch get free, and then it will just hop back to using this arena to store its temporary values. So then we can hop back and forth these two arenas to store temporary values, and then we can use the other arena to store a result. So that way we don't have any data being lost. So that's really it. So I hope you guys enjoyed the video. I will have a... well, we've got some errors here. Okay, that should be a pointer. That's a bit strange. Okay. Yeah, that works. So to pass in a reference. So I hope you guys enjoyed the video. I made a video before about hash tables and C, so if you enjoyed this video, you probably enjoyed that one as well. So thank you for watching, and I'll see you guys later. Bye.